I am based in London, but I work for Aqua. Who's heard of Aqua? A show of hands? Okay, so Aqua are a container security company based here in Tel Aviv. And we help enterprises secure their containerized deployments. And this morning I'm going to talk a bit more generally about securing your code, potentially using tools like Aqua, but a lot of the things I'm going to talk about can be done with open source tools as well. So, securing your code when you don't know where it is. A bit of a history lesson. Anybody here remember the days when we used to actually go and buy physical hardware for ourselves? A few hands. Anybody still doing that? Yeah, a few of you are still doing that. So you guys, you know exactly where your code is running because you bought the physical machine and you know where it is. For many of us, maybe a decade ago or so, we started moving to the cloud. We started using things like AWS or Azure, and we no longer knew exactly where our code would be. We'd know it's US East or Europe West, and we might have a rough idea, oh, US East, that's Virginia, but we don't know where the physical data center is. We're certainly not going to be allowed to get in and look at the machine anymore. But you can still address those machines individually. You get an identifier for each of those virtual machines that you're going to be running your code on. So you still have a pretty good idea where each individual part of your application is in terms of which virtual machine it's on. And this is a massive oversimplification, but the kind of process we would use would be a development team would write some code, some ops people would provision servers, the code would get deployed onto those servers, and we wouldn't do that very often because it would be pretty, scary and painful and things could go wrong. And in between our sort of software release schedule, security things might happen. New vulnerabilities might get discovered, and we would have to go and patch our servers to bring them up to speed with those new patches that had been found. So over time, the state of our servers would kind of drift away from what it was originally intended to be. And a lot of those changes, a lot of that drift would be deliberate. It was because of security patches. But, there's human intervention here. This is people often SSHing into machines, and they don't always get it 100% right, or they might miss one of the servers, or just something would happen that would mean you didn't know exactly what state some of those servers were in. Or it would be very easy to get to a position where you couldn't really recreate the exact state of those servers. And then DevOps happened, with apologies to all the people whose logos I've left out. We started to think about encoding everything we're doing, encoding our servers, encoding everything about our deployment as code so that we can reproduce it. We started putting our software into containers. Docker have their catchphrase of, build once and deploy everywhere, or run everywhere. And we've used CI/CD pipelines to automate everything. So we're no longer manually getting into machines, we're automating the whole process. We've got a whole bunch of tools to help us get our software and our servers into a state that we have predefined through infrastructure as code, through automation processes, through CI/CD pipelines. Who's heard of the term cattle, not pets? Yeah, okay, so quite a few have heard of this term cattle, not pets. I just love this little gif, it's great. So the idea of cattle, not pets is, well, suppose you have a herd of any farmers in the room? Oh God, there are two at the back, excellent. Right, so suppose you have a herd of cows. I'm sure if you're an expert and if you get close up enough to a cow, you can tell one cow from another. But from a distance, they all kind of look the same, and you have a herd of them. And the important thing is more the kind of collective herd rather than the individual cows in it. And if something sort of terrible befalls one of your cows, you don't get terribly upset and you just get a new one. Whereas obviously, if you have a pet, who has a cat or a dog? Yeah, so quite a few of you have a cat or a dog. I'm sure you would be devastated if your cat or dog were to, something terrible were to happen to it. So the idea of cattle, not pets, when we think about software, when we think about deployments, is you should be treating your servers, you should be treating your containers like cattle. You want a certain number of them to be up and running about the fields, but you don't necessarily care if an individual one dies, you just get a new one. So you replace your servers. And ideally, because we've got automation, we can replace our servers and we can replace our containers automatically. So we have this pipeline process these days. Again, super simplified model, but we start by writing software. We, in the same sense, we also write scripts for provisioning our servers. We build images and we deploy those images. And whenever anything needs to change, we come back to the beginning of the pipeline. What does this mean for security? And essentially, it is something that worries people. Sonatype did a survey earlier this year, DevSecOps survey, and a vast majority, 88%, said that they were concerned about security when deploying containers. And it's really not that surprising when you think about the challenge that containerization brings to security. So we now use orchestrators. We might be using things like Docker. We might be using Kubernetes. And hands up if you are using Kubernetes. Okay? Yes, in production. Okay, a few. And can I also see a show of hands if you're using an orchestrator that is not Kubernetes? Oh, quite a lot of Nomad, yeah. Any Mesosphere users? Docker Swarm users? Okay, there must be some other things. ECS? Yeah, a few ECS. What else? What else did you? OpenShift. Okay, I'm going to count OpenShift as Kubernetes. But okay, that's just for my interest. So we have these orchestrators, and they are responsible for putting code somewhere in our deployment. So we don't necessarily know where any individual piece of code is going to land. It's going to be somewhere in this cluster of virtual machines. We don't know where the virtual machines are, and we certainly don't really know which one's going to get picked for any given bit of our application. And it's pretty typical for an enterprise to have hundreds of microservices that they're containerizing. And each of those microservices could have, dozens of instances of containers running. So there could be thousands of containers. And those containers don't last very long. Datadog did some analysis of sort of data that they had collected from containers in production. And they're saying that if you have containers in production under orchestration, the average lifetime is only just a bit over a couple of days. So this is all a pretty moving target. You've got this amorphous cluster with software that keeps changing and keeps moving from one server to another. And inside each of those containers, you potentially have essentially a Linux distribution. So that's a lot of different places for dependencies to exist, and you don't necessarily know where those dependencies are. So how are you supposed to patch those containers? We used to SSH in and apply patches, but how on earth can you be expected to do that when there are thousands of the things and you don't even know which machines they're on? And the answer is, of course, you do not patch containers. You don't patch container images. Instead, we use the process that we've been talking about all along. We use that pipeline process to help us get patches into place. This pipeline is supposed to be a pipeline. It is supposed to start at the beginning and move all the way to the end. You always move in the same direction. And that's exactly the same if you're talking about applying changes that relate to security patches. We build images, we build container images, and they are immutable. If you want to add a new update into a container image, you build a new one. You never change an existing one. We run containers based on those container images, but we never modify those running containers. If you want to change the software that's inside a container, you modify the image and redeploy. So you always start at the beginning of the pipeline and follow it through to its conclusion. And by doing that, it allows us to add lots of automation for things like security into the process. We might be adding testing into the pipeline process. It's obviously not just all about building, it's building and testing. But those tests can include tests related to security. They can include integration of tools that help us with security. For example, vulnerability scanning. There are lots of different tools, things like Aqua, but also some open source options like Quay that will scan your images and look at, well, basically compare them against a database of known vulnerabilities and let you know if there are any vulnerabilities inside that image. You might want to be scanning your base images that you've taken from a third party. Who takes base images from the internet? Of course you do, because, you know, like, where else are you going to get your kind of base image for, you know, Core OS or whatever? Scratch. That's a good place to start. I'll come to that. Obviously, you don't have to get your base images from the open internet, but many of us are, because we're using, you know, particular language distributions, and if we're pulling images from, let's say, Docker Hub, we want to know that those don't have vulnerabilities in them. So it's a very good idea to integrate some kind of vulnerability scanning into the process. We also want to scan images that we've built ourselves. We could very easily be putting dependencies in that could have problems. We want to scan for those problems as well. And it's a good idea to have some kind of tooling that can tell us, well, all that software that's deployed, does it have any of these vulnerabilities? So we want to be able to use automation to tell us, okay, a new vulnerability has been found and it affects these particular container images, so that we know we can take the patch for that vulnerability, we can rebuild the affected images, we can redeploy. So the result of vulnerability scanning is, yeah, you need to do a rebuild for these particular images because there is a new patch available. You might also want to build into your pipeline other kinds of image policy checks. Again, this is the sort of thing that tools like Aqua can help you with, but you can also use other open source tooling. For example, the Kubernetes admission control checks. You might want to be testing for things like, do my container images require running as root? Because it would be better if they didn't, because privileges. You might want to have policies around what base image was used for your set of images that you're going to deploy. In a lot of organizations, there's an agreement between security, ops, and development teams around a base image or a set of base images. Maybe, you know, here's the base image we're going to use for Python, and this is the base image we're going to use for Java, so that we're starting from a known starting point, and the security team can have a good view on what's been allowed into those base images. And then you can use image policy checks to make sure that the images you're building and then the images you're deploying actually meet those kind of policy requirements. So again, automation is your friend, automation is helping you, and if anything doesn't meet your policy checks, by putting it into the pipeline, the development teams can know about it early on and they can fix it early on rather than waiting until a problem actually happens in the field. So we've talked a bit about how the pipeline can help you make sure your container images don't contain known vulnerabilities. But what about the hosts that those containers are actually running on? So one thing you can do, now that if we're just running containers on each server, you don't have to be running an all-purpose, all-singing, all-dancing distribution on those servers or on those VMs. All you need is what is required and sufficient for your container engine and your orchestration platform to work, and supporting things like logging, monitoring. There are some operating system distributions that are specifically designed to help you with this. Things like CoreOS, Red Hat's Project Atomic, Rancher. They're all examples of operating systems that have had some stuff removed because the smaller the operating system, the smaller the attack surface. So you might want to think about using one of those dedicated host OSs. We can use automation again to help us with host security. I'm particularly thinking here about things like the benchmarks from the Center for Internet Security. They have some benchmarks for Docker and also for Kubernetes. I was actually involved in a little bit of the updates for the latest Kubernetes benchmark. And those benchmarks have hundreds of tests or benchmarks, if you like, that describe the best practice for various configuration settings. So essentially, you test your hosts against these benchmarks, and it tells you, have you used best practices in terms of things like encryption settings or configuration settings that could affect your security stance. So by automating those tests and running those tests regularly on your hosts, you can see whether or not your hosts are complying with best practices. And if they're not, maybe you have good reasons for those particular settings, but at least you know about it through automated testing. Another thing that you can do through the power of automation is recycle these servers. I think this is a really powerful idea. You know, I showed that graph before of server drift. Because we're able to recreate servers through code, infrastructure as code, all those marvelous automation tools, it should be easy to rebuild new servers. So why not do that? Do that on a regular basis. Recycle the hosts on some kind of regular schedule. This helps you for two reasons. One is, if for some reason your server has drifted away from its original desired configuration, perhaps because somebody has attacked it, well, you can, by restarting it, you've pulled the rug out from underneath that attacker's feet. You've reset it to its desired state. The other thing that is beneficial is it's like a fire drill. You have tested and you are testing on a regular basis what happens if you destroy a server and recreate it. So knowing that that can happen in your sort of normal day-to-day production, it means that if you have an emergency, you know that your processes work already. It's all about treating your servers as cattle and not pets. There's a good blog post by Diogo Monica from Docker that talks about the concept of reverse uptime, which is essentially this idea of measuring how long your hosts are actually up for and having some target for the maximum of that. That you don't want your nodes to last for longer than a particular metric, precisely because of this recycling idea. There's no reason why you can't also use your existing security tools on your containerized deployments. In fact, there's an argument that says that intrusion detection can work better on a container deployment than on a sort of traditional deployment, because they work by looking at changes in the file system. And if you're running containers on a node, the containerized code is in a particular part of the file system. So changes in the rest of the file system, anything kind of weird and unusual, possibly an exploit happening, they should be easier to detect, because we should have much fewer reasons for example, for individuals to log in. There are no real reasons for individuals to log into these cattle nodes. So our existing tooling can work more effectively in these environments. And then there are some things that are characteristics of containers themselves that can help us with security. So the first one of these is the idea of reducing images. And I've got a little, one of the things I've got running on here is a very small web server called Hello. These are both windows into the same virtual machine. And if I go to that, oops, 8081, I think it's on. No, it's not. 32768. There we go. So there is a web server, very simple bit of code running there. You're all awake, yeah. Now, can I exec into that container image? So suppose that what's it called? It's called Hello. Suppose that I try to run a shell into that running container. I can't do it because there is no shell inside that container. Now, if I was an attacker, the fact that I don't have a shell is going to make it a heck of a lot harder for me to do anything attacky with that particular container. And the reason why I can't shell into it, why there is no shell, is because I built that as a super, super small image based on the Scratch image. Scratch is literally nothing. There is nothing in the file system except what I copied in myself, which was a hello binary and some template files. That isn't going to be suitable for everybody. Not everybody is in a position, particularly if you've got legacy code, and depending on the languages you're running with, you can't necessarily just use a standalone binary executable in all your container images. But the point here is to illustrate that the smaller you can make the containerized code, the less code there is in there, the fewer tools you put in there, the less useful that particular container will be should somebody manage to somehow get inside it. Reducing the attack surface is a very good thing. It also has a whole bunch of other benefits around it being a smaller image, it being easier to pull, all sorts of good things. Also, there clearly can't be as many vulnerabilities in an image that doesn't contain libraries, dependencies. Another benefit that we get out of microservices and containerized code is that we no longer have like one great big monolith. We have these isolated pieces of code, and we can reason about which bits of code should talk to each other. And then we can use tools to limit communication so that only the communications that we expect are allowed. Things like Istio and Envoy can help with this kind of thing. There are also other tools like Aqua available. And these tools can make it easy to limit which containers can talk to each other and encrypt those connections between them, making it a lot harder. Again, if somebody does manage to exploit one container, it's much harder to move laterally from there to other parts of the system. Another thing we can reason about with microservices and containerized code is what those containers are supposed to do when they're actually executing. If you've got a monolith it's really hard to, in theory, you can say, I know exactly what my code is supposed to do. But the reality, as we all know, is there will be error paths that we've never seen before because monolithic code is complicated. If we're really in the fortunate position of having microservice code that really is broken into kind of nicely isolated bits of function, it's much easier to actually say, yeah, I've got tests that execute all of my paths, that execute all my error paths as well as the happy paths. And I can have a much better view of what each container should be allowed to do. And if we know that, and we can detect what it's actually doing, then we can flag up unexpected behavior. That can be a red flag telling us that something bad is happening to our deployment. And I'm going to do a little demo to kind of show the principle of this using a vulnerability called Shellshock. Has everybody heard of Shellshock? Yeah, quite a few of you. So Shellshock was an exploit a few years ago now in Bash that basically meant you could execute arbitrary code. So let me find my window again. Right, so I have here a very small web server running. Well, it's an Apache web server. It's running a vulnerable version of Bash inside it. And if I go to, now this one is on 8081. So there's a web page there, it's some Apache thing. I also have some CGI scripts, which, so CGI is the kind of old-fashioned way of creating dynamic web content. And there is a CGI generated page from this web server. And I also want to check that there is not currently anything at this particular address, env.html, because I'm going to attack that. So, or my attack is going to create that. So at the moment, env.html responds with a 404. There is no page there. So I'm going to run another container which is going to attach to the web server process ID space. So that's container Shellshock. Oops, if I can spell it. And I need to give it p-tracing capabilities because I'm going to use a utility called STrace. And I'm just going to use an image that has Ubuntu with STrace installed. Okay, so hopefully I can see from here, yeah, I can see my own processes inside this container, but I can also see the Apache processes that are serving that website. And I'm going to use STrace. I'm interested in a system call. So STrace traces system calls. And I'm interested in the system call execve, which is what's generated when you run a new executable. It runs a new binary for you. And I'm going to look at these processes. Looks like I want 8, 9, and 19. And I'm going to follow any child processes that they might create. Okay. So now if I hit that CGI page again, we can see that that actually did some execution of that CGI script. And that's what we're going to consider normal behavior. That's all good. So now I'm going to use the Shellshock attack on this same server. And I do this by passing in a user agent string and a little incantation so that I can now run some arbitrary code. And I am going to run env, and I'm going to put the results into a file which corresponds to that env.html address that, oops, /env.html. So that's the page that didn't previously exist. Okay, now that generated a 500 error for me, but I'm a hacker, so I don't care about that. It's fine. What's more interesting is over here, we could see the CGI script got run again, and then we could see that bash got run, and then we could see that env got run. Now, I'm not an Apache expert. I'm not going to tell you that there is no reason why it shouldn't ever run bash, but I am going to say, is there really any reason why it should be allowed to run env? If I go back to that page again, we can see that that has generated some potentially useful information for me. I can get the info. I could have run any command I liked through that attack. So if we were able to say, actually, we're only going to allow a certain set of executables, then we could restrict the ability of an attacker to take advantage of that exploit. Now, I'm not saying that, yeah, all run fine, it's fine to run with Shellshock if you've got this kind of protection. Of course it isn't. The point is more that if you have tools that enable you to check, for example, which executables are being run, then that could protect you in the event of there being some kind of vulnerability. Serverless is, I just wanted to mention serverless because it's another example of code that you don't really know where it's running, and in some cases you don't even really know what the code is. So what am I talking about when I think about serverless? Well, first of all, do you need to think about security when you're running serverless code? And well, I would think it's probably a good idea to at least understand what the sort of security measures have, what kind of security measures are in place, and to understand what's going on under the covers a little bit. And serverless, really, I'm thinking of two sets of things. One is managed services, so things like RDS databases or BigQuery. You can go to your providers like Microsoft and Amazon and Google, and they can provide you with amazing tools like databases that prevent you from having to worry about setting them up. And to some extent, particularly, depending on the size of your organization and your particular application, perhaps it's better to leave the configuration of some of these services. We use managed databases because it's hard to manage a database. It's hard to manage things like replication, and it can be hard to manage things like security. So provided that the provider of these services is doing a decent job of security and you're using their controls effectively, that can be a good solution. That could well be better than doing it yourself. The other set of function that everybody thinks of when they think of serverless is functions, some kind of functions as a service, things like Lambda. Is anybody using functions? Yep, a few hands. If you're using them, are you using them in production? Hands up if you're actually using them. Yep, good, okay. So this stuff is really taking off very quickly. And the important thing, I think, to recognize, or one important thing to recognize, is that functions are essentially running in containers. This is, a screenshot from the AWS documentation. When you run a Lambda function, it is running inside a container. Again, there will be a ton of things that Amazon or the equivalents from the other providers are doing for you in terms of security. But it's good to be aware. It's good to be aware that things like the runtime that your function runs in, if it has vulnerabilities, it's just code, right? The vulnerabilities could be there. So you want to know that if you're shipping containerized code to the function, to the extent that you can control that container environment, you want to make sure that it doesn't contain vulnerabilities to the best extent you can. So I'm going to just finish up with some advantages that by being cloud native, by using automation, by using DevOps processes, some advantages that we potentially have for security. So one is this idea that we're decomposing the problem. And just as containers and microservices let us decompose an architecture problem, decompose a software design problem, we can also decompose the security defense problem. And by securing our individual containers, we can add extra layers of defense over and above what we used to have in traditional deployments where we protected around the whole application. We have the advantages of continuous deployment. You don't have to be automating the full deployment process to take advantage of having a pipeline. Even if there's a manual step before you actually deploy, it's much faster and easier to deploy your code in cloud-native pipeline processes. And if you can deploy your code easily, you probably do it much more frequently. And when you redeploy your code, you reduce the time in which an attacker could have exploited the previously running code. And the last thing is, I think, in the kind of DevOps world and in the sort of cloud-native world, there are some really good communities, things like this event, where people share best practices and they talk about, what has worked for them, what tooling, what automation processes, what organizational structures have worked for them. And we can use that to help in the kind of collective fight against security exploits. We did a survey at Aqua just a couple of months ago, and 80% of the respondents to that survey said that they felt there was room to improve the security of their containerized deployments. So, there are lots of best practices still to be shared, lots of things we can learn from each other. Couple of quotes from the Enterprise Strategy Group. One was, containers require us to be collaborative, and that's part of what days like today are all about, thinking about how we can collaborate better. And also that it's a good idea to embed security early into the process. I actually think there's two different ways of interpreting this particular quote. One is, it's a good idea to embed security automation tooling as early as possible in the pipeline. The earlier you can report security issues to the development team, the faster they can address them. I think you can also interpret this sentence to say, when you are thinking about your pipeline, your organization, your DevOps or DevSecOps structure, it's a good idea to think about security early on. Don't sort of have security just as an afterthought, because you can build it into this pipeline. If I leave you with one thing, we already talk about continuous integration, we talk about continuous deployment. Let's also think about continuous security through the process. There is a link to the survey results that I just mentioned, and also a link to the KubeBench tool. This is the automation tool it's an open source tool for automating the Kubernetes CIS benchmark, and something that we've been working on at Aqua. So with that, I don't know I've no idea how we're doing schedule-wise, but I probably can take some questions, I think. Yes? Good. Yes, I have the okay to take some questions. Any questions? Yes.
We can count on.
So the question is, Docker Cloud has some security sort of scanning and alerting built in, and is that sort of something that you can rely on? I am going to say it is considerably better than nothing. Definitely use it. Why not? It may not be everything you need, depending on your application, but it's a start. I would definitely use that over nothing, for sure. One of the interesting things, though, when you look at these vulnerability scanning and alerting tools is false positives. And the dedicated tools will tend to be, like Aqua, will tend to do a better job of not giving you false positive results. Okay, I think that's it. Thank you very much.